Hello and welcome to a really quick video on just how to use this little node that I made. I'm not gonna lie, I did use some cloud code generation to figure out the nodes because I'm not great with maths and I needed a quick solution. But yeah, so I'm assuming whoever's following this, you already have like a basic Earth of some kind set up. And yeah, so in this example, I literally just have the most simple Earth ever. I'm thinking of doing like a longer tutorial with like parts to it, with like, like here's how you do each step, kind of like what Sam did, but for EV. I'm thinking of doing something like that. But for now, let's just focus on this specific thing, and then if I do a tutorial, I'll delete this video and incorporate into that. And I'm not going to edit this much, I kind of can't be bothered. So yeah, here I just have like a UV sphere, and for this node to work, you do need to use a UV sphere because it's using, it's converting the lat-long coordinates into UV coordinates, and it just kind of only works with a UV sphere. So yeah, I have my Earth set to, and this isn't really important, but this is the size, but this will work for, 2 meter, or however wide your, whatever the diameter is, doesn't really matter. And yeah, right now it's, I haven't put any of the other maps in, it's just the ground, but that makes it a little bit easier for us to explain how this thing works. So, the first thing you want to do is download QGIS, and actually before that, let me explain what we're trying to do and why it's important. So let's say you've got an Earth map in your model and you want, for example, Madagascar in high resolution. Like here it's pretty low res when you get close to it, but maybe you're doing an animation or a shot where it's something, I don't know, like this, and you want this in high res just so it look a bit nicer. Or you're doing like an animation where you're zooming out of somewhere and you want to come out to a wide, and you don't necessarily want to have to download all of this entire thing multiple times. And you can like split it up and then map the UVs for different places manually, but the whole point of this is that it kind of does it really accurately, and we don't have to do much guesswork and figure much out ourselves. So it's like the lazy and accurate way of doing this. So we're going to look at QGIS, and I'll show you some of the basics of this program, which I think everyone should download because it's very useful. You'll be met with this screen, and you click new empty project, we've got nothing, and QGIS is like geographic imaging software. It's used for like scientific purposes mainly, and like creating maps that display different data and things like that, and you can do some Python stuff, it's very useful for visualizing things very quickly. I have a bunch of maps added here, and I'm going to show you how to do that. So what you want to do is click up here, or press Ctrl-Alt-P, and you get your Python console, and then go up here to click Show Editor, and we're gonna just copy and paste some code from here. I will put a link, in fact I'll just copy and paste this code into the description of this and put a link to it, to where I got it from. Get back in QGIS, copy it in, hit run, and then close the program and open it again, and you will have all of these added. And here you can pick like different satellite data providers. For example, we've got Google on here, so you'll recognize like Google Maps. And yeah, as you zoom in, the resolution is updated because it's basically fetching all of this data from like the Google server, I guess, or something like that. And yeah, you can get very close to things. And what's good about this is you can export this as you see it on here. So I like to use Esri just because I like the look of the Esri map a little bit more than the Google map. And yeah, what you want to do is zoom in on an area you want to download in high res. You can be very specific about this and create like a shape layer, which just can crop which bit you want specifically. But another way is just to kind of use the screen to figure it out. So let's say we want this, and then right click on your layer, go to export, save as. We want rendered image. I won't lie, I don't really know the differences between these two. I don't think it matters when we're dealing with this kind of imagery, because there is no raw data. This is all processed from Esri as is. Uncheck create VRT. Creating VRT kind of splits up the file into multiple pieces, which we don't actually want right now. And this is important. Change your CRS, which is your coordinate reference system, which just determines how the base map here, and this is called a base map, is viewed. And in Blender, you'll see that the NASA base map that we're using is it's in this format, which is EPSG 4326, not EPSG 3587. So what you'll want is for, you know, it to be the right format, basically. So down here, click on this, and click this, and apply it, and now it's in the correct format. So yeah, again, just go ahead and find the area you want, I don't know, something like that. And right click, export, save as, rendered image, no VRT, and then here the extent, we want it to be map canvas extent, meaning what we're looking at in the canvas. And these numbers are important because we're going to use them later in Blender. So I recommend just, you know, get a quick snipping tool of those, because you'll need them in a bit. Or better yet, copy and paste them into like a notepad or something. In the past, I did make a thing in Blender which could just grab these coordinates out of the GeoTIFF image, but it requires you to download some Python libraries into Blender, and it's a bit like annoying to get that to actually work properly. So I sort of just can't be asked. And here, change your CRS to EPSG 4326, and then this is important. So when you're dealing with geographic data and GeoTIFFs and NetCDF files and all these other like more like scientific file formats, which aren't necessarily for visual effects. Sorry, I had to yawn. Yeah, when you're dealing with these kinds of files, they call the same things different names. It's a bit confusing, but columns and rows are just to do with pixel resolution, so like pixels X to Y, basically. So if you had like 1080p, you'd have 1920 columns by 1080 rows, is the same as by 10 pixels in X and Y. I don't know if that made sense. But anyway, right now we're getting 2 pixels by 2 pixels, which we don't want, so type in 0.01, and yeah, the lower the number is, the higher resolution you're going to get. For example, if we wanted this like 5K image, we just copy that same number in, so the resolution, you know, is the same ratio. And that's what the resolution is going to be, and then you know, just select where do you want to save. I've already saved this one, so I'm not going to do it again, and just press OK. And when that's done, just the area you want in high res. And yeah, you can of course like make another one more zoomed in, whatever you want, or like go higher res than this if you like, whatever your computer can handle, really. And this is a GeoTIFF, meaning it is a TIFF file which has geographic data embedded into it. And the main thing from that we need is the top left, top right, and bottom left coordinate. And Blender will take those and convert them into UV coordinates, which will map this perfectly onto our sphere in position where we want it. So yeah, once you've got your image, jump into Blender, and those numbers from before, I've written them down here, and this is the order that you'd want them to go in, so yeah. And on this, very usefully, we have a mask preview of where our image is going to go. And if I just open our image, Madagascar region 1, It's currently untiled, so you want to change this from repeat to clip. I mean, we can also mask, but yeah, we're just going to use clip for now. But you see, obviously it's not like layered right now, so if you know compositing at all, this will make a lot of sense. We want it to appear on top of our base map down here. And to do that, by the way, it's Control-Shift to quickly preview. That only works if you go to Edit, Preferences, and turn on your Node Wrangler add-on, which is really useful. So we want to mix these two. So you could type in Shift-A and then mix, color, or whatever, but another way is to hold Shift and Control and do right-click mouse and drag, and it will do it automatic. So right now, yeah, you can see we're fading between the two. And I don't think we're using the high res, so yeah, we're not. It's layered the wrong way around, so to fix that, we just do this. Swap them around. And now, yeah, I think it's the right way around because it's on top. But you'll see, like, you know, we don't want those black here. So if we grab this mask preview or alpha, it doesn't really matter. Basically, that is just the transparent, where this layer, where this image is transparent. And in this case, we don't have any transparency. It's just like a flat thing. So we can use this in our factor, and that just tells it where to mix between the two. So it's telling it to mix, like, don't just in here, basically. And yeah, just like that, we've got it. High res is perfectly aligned. You can see the line where it changes. If you want to, what you can do is grab the alpha of this, or even in Blender you can edit it and just soften it so you get softer edges here. I can't be bothered to do that right now, so I'm not going to bother. But yeah, that's basically how that little thing works. It's just a bunch of maths. I'm sure it's not actually very complicated. I will try and explain how it works, but I only kind of get it. So that's the workflow. And yeah, you know, turn your atmosphere and whatever else on if you want. And keep blending, I guess. Hope that was useful.